welcome to this interview session. My name is Sarah Teke and I'm in charge of communications at the AIMS-Cameroon Center. So before we begin with the interview, please permit me to introduce my interviewee for the benefit of those who are going to be watching this video later. So at age 15, Arran Fernandez gained admission into the Cambridge University where he started studying mathematics in 2010. Making him the youngest to attend the university for more than 200 years. In June 2013, he became senior wrangler at the Cambridge University, and he's thought to be the youngest senior wrangler ever. After graduating with distinction, he went ahead to obtain a master's and doctorate in the same university at the Department of Mathematics and Theoretical Physics. He later joined the faculty of Eastern Mediterranean University in Northern Cyprus, where he's currently serving as lecturer. Professor Arran Fernandez research interests are in fractional calculus and analytic number theory. Thank you very much once more, and many thanks for joining us yesterday to school 30 participants on fractional calculus and zeta functions during our first virtual colloquium organized by Dr. Njida. To begin the interview, I would like to find out the main aim of your talk on fractional calculus and zeta functions.
Okay, firstly, let me say thank you very much for the introduction and for this opportunity to speak in an interview. Thank you for inviting me here. So you were asking about what about the aim of the research in fractional calculus and zeta functions?
Yes, sir.
So this is something I tried to motivate in my talk yesterday. So fractional calculus, from my point of view as a mathematician, it's a more general version of the calculus that every math student learns. Even at a low level, you learn about calculus, you learn about differentiation, integration, and so this is a way of making those concepts more general. It turns out to also be useful in the real world in, for example, modeling non-local interactions or viscoelastic materials. My interest is from the mathematical point of view. I'm working in mathematical analysis, which from that point of view, you can study both fractional calculus and zeta functions and connect them together. The zeta functions are part of analytic number theory, which again draws together two different parts of maths, analysis and number theory. And again, I'm coming from the analysis point of view.
So moving on, could you tell us how you got interested in this field?
Well, fractional calculus was something I was interested in as an idea ever since I first learned calculus, because I asked this question of what happens if you generalize. So you can do calculus at these fixed points of the whole numbers, 1, 2, 3. So I wondered what happens if you go in between. Can we give meaning to this idea in between the whole numbers? And at this time, of course, I was not even at university yet. I didn't know that this was a big topic of research, but I was lucky enough that this question I was interested in, it's now an active field of research. Many people are working there, so there's many opportunities to research in this field. And zeta functions or analytic number theory is something that lots of mathematicians hear about at some point, the famous open problems like the Riemann hypothesis, about the Riemann zeta function. And so it's a very sort of glorious topic to look at. And again, I was lucky because my PhD supervisor was working on these zeta functions. And so I had this opportunity to work on some big problems together with him.
So I know that after your talk, a lot of participants were curious as to the applicability of these theories in various mathematical fields. So according to you, what were the major concerns of the participants and how were you able to clear their doubts?
Yeah, so somebody asked me yesterday about how these fractional calculus, fractional operators can be modeled numerically, how they can be sort of calculated if you have a computer, and also about how they can be understood in terms of physics or in terms of geometry. Now, the latter question about physical and geometrical interpretations, this is one of the sort of big open questions of fractional calculus, because nobody quite understands geometrical or physical interpretation. These things were invented as a mathematical abstraction, and now they have discovered applications, but the applications are mostly because this is to fit the data that emerges from some experiment, and it's not really understood why this connection exists. As for numerical calculation, that can be done. There are different models of fractional calculus. Some of them are better for doing this approximation, doing this calculation. But again, this just comes from the point of view of here is something we can define mathematically, and even without connecting to the real world, we can still do these calculations and approximations.
Finally, I know that you have been collaborating with the acting chair of the AIMS-Cameroon Research Center for close to 2 years now. So I want to find out how you feel about the collaboration so far and your expectations as to this collaboration.
Yeah, so my collaboration with AIMS currently, as you know, is mostly with Dr. Jida, and I first made contact with him while he was still, well, in fact, we were both still PhD students, and we collaborated together at that time. We wrote one paper together, and then we kept in contact, and I came to Spain to visit him and his group twice, and we're working on some very good and very interesting projects together. We've also co-supervised a master's student together at AIMS-Cameroon, and there is a lot of potential, I think, in the work we're doing. He's perhaps one of the best quality mathematicians that I've worked with, and these projects that we're working on, they're not just a finite length project, but something that can go on into the future and produce many new ideas and new work.
Thank you very much for attending this interview. Thank you for all your support to AIMS-Cameroon and to our vision. We hope that you could visit us here at the center sometime in the future. Thank you so much. Many thanks, and I wish you all the best in all your future endeavors.
Thank you very much. And yes, I would like to visit one day when this COVID situation is over. I hope to be able to visit AIMS-Cameroon and meet the people there.